Okay, so this is our contactor. Contactors are basically just a switch. So whatever you feed in one side, when the switch clicks in, it comes out the other side, just like a light switch. So if we look at how contactor works, it has the switching part of it is what you hear when your controller shows heating, and you'll hear it click off. You hear it click on, and you hear it click off. And that's what it does. This, if I take this apart, so here you can see, just to show. So on the one side, we will have L numbers. It shows L1, L2, L3. This is where our supply comes into a contactor. Where we go out are marked T1, T2, T3. We generally don't use the fourth one. If I take it apart, so a contactor is in three pieces. There's a bottom, a top. The top and the bottom contain the contactor plates. In the middle is a, what do you call it? It's the coil. Sorry. Okay, so you got a coil in the center. The coil, when it's energized, puts electricity through the coil itself. I'll explain that now. So basically, so we have our contactor. When it's taken apart, okay, what you'll see, there's a top part, and you've got contactor plates on that. Then you've got your coil in the center, and the coil pops out. Just get that out properly. Coil comes out, and you've got your bottom contactor plates. So what happens when the coil energizes? Then it puts a magnetic field which pulls the top contactor plates towards the bottom ones. So you can see that's your clicking that you hear. As it clicks in, it moves, and you can hear it. That contactor plate, these three contactor plates, will then connect these three at the bottom, and that is basically your switch. And so if we just to look at this, so coils come in various sizes. We use a 240, which means that the power coming into it is 240 volts. You do get them where you get a 12 volt, or you get a 24 volt, or a 48 volt. What happens to a coil when it blows? You can actually see the difference, and you can see how this is blown. And so what happens is the wiring sort of explodes, if you want to call it. It doesn't explode, but it expands, which will also push out the center of the coil, which will prevent the contactor from closing. The reason this one happened is because they'd put a 24 volt coil, but put 220 volts through it, and so that blew. So anyway, so just to leave that out the way at the moment, that's how a contactor works. The other thing to show is, so I did show that we have L1, L2, L3, where our power comes in, and then we've got T1, T2, T3, where your power goes out when it connects. So what makes it connect is that you've got A2, and on the other side you've got A1 and A2. A1 and A2 on this side and A2 on the other side are common. And so if you look at the contactor, you can actually, those are your two A2 sides. They come together, it's the same thing. So whether you use the one or you use the other is irrelevant. It really comes whether you have your A1 and A2 wires on one side, or if you have them on opposite sides. So your wires on that is your, so yeah, you've got, so it will be on A1, A2, and one will be your positive, your positive and your negative that is going to feed the coil. One of these generally, so your negative remains negative in line with all the other negatives on the system, and then your positive is fed from your controller. That's your signal wire, your trigger wire. So as soon as that sends your signal through, the coil is energized and the contactor makes contact. And so that's how they work. To show how they're connected, if we have a look at this, now there's a lot of wires in this, which are just, these are nothing other than connectors. And so, you're getting a big wire going to a small wire. It could just as well be a small plastic connector. These are bigger. It's a different system. it's just still a connector. So on this one, you can see we're using a single phase. And so because we're using a single phase and we've only got one element coming out on the other side, one wire that is feeding an element, it's fine to then take our negative also through the contactor, because it just means when the contactor goes on, both positive and negative are energized, or you got to go through to both. So this would be a single phase coming in, going to a single element. So a single element, remember your element that's inside the kiln could be a single element that is divided in half, and where it comes out at the back, they make it common at the top, which means it's still one element even though it's cut in two halves. So this would be feeding one element. So when it comes on, our element comes on. So that would be one option. Then you could have where you have a single phase coming in, but it's feeding two separate elements. And so this would be on something like, a 700 that has got two 20 amp elements. I think it's a 600. 600 has two 20 amp elements. So we feed it with a single phase coming. Our power coming in is the single. Our negative would go outside of the contactor. And so we've got our power coming in, but then it's going out to two elements. So in order for both of those to be fed, we bridge the first one coming across. We just randomly have chosen T1 and L1 and L3. It could have been L1 and L2. It's just a bit harder to put when they're so close together. So we've gone and missed one. So you've got it coming in, you've got your power coming in, you bridge it across here,